Sorry,
Hello.
I'm running a little late today. Hey.
Hey, everyone.
So I guess we'll just wait until 8:05 and then get started. How are you guys doing? I mean, how's the class working out for you and everything else?
Pretty good.
I had trouble with the midpoint, Carol. I got it to work on some of the worlds, but other ones I couldn't get it to work.
Okay. For the midpoint, Carol, actually, the second approach that we took in the last class, that should be like maybe something you should look into, with the idea being that like you want to make a generalized solution, which will then just, work almost everywhere.
I got it to like lay the beepers across the row and then go back to each side and like eat one at a time. But it didn't work on the single one.
Okay. Actually, yeah, I will later today or maybe tomorrow, dependingly, I will start posting these little, there are these little interactive IDEs you can embed in Ed. So then we can like maybe work through the solutions now that it's, I mean, it's over a week. So
Yeah.
Yeah. So I think we have 1, 2, 3, 4, 5 people. And one person won't be joining us today. So yeah, that's almost 50%. So yeah, shall we get started?
Sure.
Okay, excellent. So did you guys cover the material this time? I mean, of course, we'll go through it as well, but just wondering.
Yeah, the handout. Yep.
I didn't have time to cover it this week. But
Okay.
I also have had a question about the assignment last week.
Okay.
We can get any solution because I had some difficulties with the third task. So I don't know. You can go through that.
Sure, we should do that. But first, oh my God, this is actually for something later today, I need to use Windows, so I'm stuck with Windows and it's really annoying. But okay, yeah. Right, so everyone can see Moonweight? Yes, no.
Yep.
Oh, yeah, yes. And of course, please feel free to mute yourself, unmute yourself as and when you see fit. I am completely unsure of how to work this on Windows, so I'm not going to be doing any meeting control. So let's talk about Moonweight. And in general, before that, let's talk about variables. So would anyone want to tell me what you know about variables?
They're used to assign a number or text.
Okay.
And identify that.
Okay.
And you can store either strings or numbers in variables. And that we need to use the apostrophe, or I forgot the name of the other one.
Okay, so in fact, right, I should be keeping the notes. Just give me a second. Does anyone have the link to the notes handy? If you could send it in on the chat, that would be great. Or I'll just pull it up in a second. Right, so we've like there's some very interesting points that you guys raised, which is that variables store things, right, or strings or values or something, right? Section 1. And okay, but more generally, like, why do we need a variable? Like, where is it storing this and what is going on? So I'm really sorry about being a little messed up today.
We need variables in order to store the information so that we can use that information later in the code.
Okay, so that's a very good answer, but what we're really doing is exactly what you said. So let's start with that. What are variables? We discussed that we put them in memory, use them later, right? What else? And in fact, someone already mentioned that. And the other part is types or labels, right? We need to know. Okay, now here's another thing. We don't actually, so when we say that, okay, suppose this is, okay, the bigger box represents the computer's memory, because now we need to actually deal with what the program does when it runs, right? And what it does is it has this little space in memory, kind of like our brains, and then you start storing things in it. But when you store things in it, then you should also keep track of what this is. So say this is a string. Okay, can anyone tell me what is the difference between calling this a string, right, versus calling this, I don't know, one, or as Mia mentioned,
Quotation marks.
sorry,
The quotation marks.
quotation marks, but those are syntactical. So those are all very good points, but those are more related to do with Python itself. But really, variables are something which are part of every single program you will ever write. Okay, there is no programming language, there's no way to communicate with the computer without using variables, right? And so the question is there something special about what the variables represent? Like, why do we have a concept of strings? Why do we write strings in quotes? Or, why do we do this?
When we use strings, for instance, if we type 9 or 5 as strings, we cannot do mathematical operations on them. For instance, if 5 is a string, we cannot add other numbers, digits to it. So that's why the main distinction between the string and number is that with strings, we cannot do mathematical operations.
Okay.
And to add further, like strings are texts. So it's a text and not a number.
Excellent. So now that brings us to two very important things. What we've now defined is we want to label our variables according to what they do. That is the operations we can use on each of these variables, right? Like plus or minus. Does anyone have an example of a string operation? Something which you can use with a string, but not with numbers.
Print.
Print actually, well, in fact, the best way to check is, can we print something? So let's just check it out. Print 9.
We can also concatenate strings by putting plus sign in between the strings. We can concatenate them.
That is a very interesting point. And in fact, okay, so first of all, we see that we can actually print, right? We can print both variables and strings. But, okay, concatenation is special. Concatenation, that is an interesting thing to bring up, especially in Python. Concatenate. Okay, what was the second thing we talked about? Labeling them, right? That is, they represent types. So someone said string, or something mathematical, like maybe an integer. And here we'll talk about something else. Suppose I give you a sentence and I tell you to memorize it. Now, and then I give you a single digit and tell you to memorize that. What changes between the two? Why is it different? Hello?
Can you ask that again?
So I'm saying that suppose you as a person are given a single digit to store in your memory versus a whole page or a book or a text or a dense amount of words to memorize. one is harder than the other, right? One takes up more space,
Right.
right? And that brings us to a very important notion of, and you'll recognize this inherently when we make this box. Whenever we say this is the computer's memory, we are also saying we have a finite amount of this, right? It's gonna run out. And in this finite amount, we can store digits, right? Or we can store words. But we recognize that some of these take more space than the others, right? And at this point, this is really all we need to go into this at the moment. We'll probably cover this in more detail in the course, but the very fact that these take up different amounts in memory, okay, should tell you something about why they're different, you know? So it's not just the operations, even though the operations are extremely important. And the reason why I said concatenate is interesting is, let's see if we can't get an example. But wait, maybe we're getting ahead of ourselves. So we've done what are variables. We'll come back to concatenate. Okay. So what does any of this have to do with Moonweight? So have you guys read the description of Moonweight?
Yes.
Okay. So now Moonweight is a nice motivating example. I have some personal history with Moonweight. Moonweight is the example which I presented in order to get to teaching all of you. So I have some personal history with it, but also it's a beautiful concept because what we're doing here is that we're saying, okay, given a weight on the moon, on Earth, and then we have an equivalent weight on the moon. And this isn't going to be a physics class, so we're not really going to go into which units we're going to be using and all of that stuff, right? But inherently, what could be the problems with this? Like, what are the steps? Let's break it down like we did last time. And once we break down a little bit of Moonweight, we'll come back to variables and discuss in more detail once we start seeing how to work with variables, right? So breaking down Moonweight. All right. So how do we decompose this? Okay, so let me read it out. We need to write a program to calculate the weight on the moon given their weight on Earth. And so the user will enter a weight on Earth and the program will print out the corresponding weight, right? So how can we break this down?
So first the user has to enter the weight. So we have to write a string for weight, enter a weight, and then maybe
I'm sorry, I'm not sure if you're breaking up or if my network is bad. Could you tell me what you said after input?
Yeah, I said that first we have to let the user enter the weight. So we need a string like a sentence, enter the weight, and then convert it into an integer so that we can perform an operation on it.
Okay. Right. So in essence, then, okay, I don't know what to do with this box. I'm just gonna move it to the other side. Okay. Right. So in essence, we have an input, but then, okay. First question. Everyone is clear with this, right? Everyone agrees that we have essentially 3 steps. We'll get the input, we'll convert the input, and we'll say print the input. Yes.
Convert the input into integer and then perform function. Like, do you want to write it?
Okay. Now that's an interesting point because why an integer?
Or I mean, yeah, or a float, like a real number. Maybe
Okay.
a real number would be a better idea.
So let's go back to discussing variables for a few seconds. What are the different types of variables which you guys have or are comfortable with at the moment? String, int, real number, which in Python is called, don't worry, you can look it up. It's called a float.
Float.
Yes. And anything else? Well, good news is we don't need any more, so that's great. Right, so we have input conversion print, and it sounds like, okay, it's similar to, oh, by the way, does anyone have any questions about what you see here, like moonweight.py, like anything about this? Like, you know, it's different from Carol, and
It's a Python program, right? It's not like a Carol reader or anything.
yes, it is a Python program. And so, you know, we will run this, as you all know, from here, right? Everyone is comfortable with this?
What would happen if you remove that last line?
Excellent.
If name.
Okay.
Yeah.
So at first we'll try it out, and then, so the first thing about programs is 9 times out of 10, if it crashes, nothing bad happens. There are some cases where that's not true, but none. Okay. So we see that we got a syntax error, and the syntax error says unexpected EOF while parsing. Okay, now EOF stands for end of file, right? And there is something, there's a little bit of interpretation which this needs. So let's do that here. So Python will read in a file, and then it'll perform what is called an interpretation of the file, right? And this is different from some other different forms of programming, but what's important to recognize here is that, you know, this point is the most important. It will read in a file. And so why would it say end of file, right? I mean, it told us end of file, and we see that, hey, wait a minute. So first of all, you see this line 13. Now, does anyone know in a file of 12 lines why it is even looking for line 13?
That's the last line after the code.
Excellent. Yeah. So very simply, it is reading it in line by line. And in fact, that's where the name interpreter comes from. So it'll interpret it line by line. Okay. So which makes Python a popular language for doing these kind of line by line operations, because it'll break at the right position. And the other kind, which you'll actually see more often, is all the exes and all the other kind of programs that you run. So those are typically what are known as compiled ones, which means they are compiled in advance and they just run when you want to run them. But okay, getting back to what Python does. So we've discussed that Python will go in, right? Say this is our input file, and it starts reading it. Now, can anyone tell me, we have this function here, right? But we're defining it. We're not actually running it, right? Like, everyone is clear as to why this is not executing this function here, right?
Yeah.
Yep.
Okay. So now that brings us to this. So an important thing to note here is that there's nothing really inherently special about main. And this is something which I feel is, I mean, it trips me up sometimes. I mean, honestly, what would happen? Ideas? Would it run? Would it die?
Will it still be looking for main?
Let's find out. Turns out no. And okay, now that we know what it did, does anyone know why it did that? Okay, so we're comfortable with the state space interpretation, which we covered last time. Remember when we said that you have a for loop, you start from one position and you go to the end state, right? So when a Python program, when it opens a file, it's true, it is an interpreter. It does read it line by line. But now here's the question. Which line do you think it starts at? In this small code of 12 lines, we ran Python, right? We run this code. Where is it starting?
From line 6.
From line 6. Okay, interesting. So how do we test that? How do we test if we feel like it is line 6 which is running first? Let's find out how we can test that. We raise an exception. Let's make an error. Something. This should not run, right? We're all clear on that. Let's see how that works. Okay, so good news. We do have an error, but the error is interesting. You see, the error says that the error started at line 13. And in fact, that kind of gave away the answer. So you see, what it does is, it is line by line, but it is starting from the state which is defined by here. So you start from this name state. What that means is, wow, Windows is slow. This state, oh, one person is waiting, sorry. Let me just, wait. I feel like I didn't get the person in. Sorry, just a minute. Okay, she's in. Hi, Asma. Okay, right. So where were we? This state, this entry point, is known as name for historical reasons, which is to say that it is essentially the name of the program. I'm not good at drawing things. And so the program starts at this point called name, sorry. Now, when it's in name, it doesn't really know where that name is, right? So we can move this around and essentially get the same thing. So if we move this, say here, right? And just for the heck of it, let's not have the error. Oh no, wait, we need the error. The error is important. Ooh, okay, fun. What happened now?
Is it because it has to go line by line? It didn't reach RBF first?
Exactly. So we've realized something. We read in a line, yes, but there's a little bit of more stuff going on. So it interprets it line by line. We saw that. But it executes, or it starts running the code from this state. So is this something which grew organically for everyone? Does everyone feel the same way about this? Like, okay, let's see if everyone understands this. Oh wait, there's the chat.
So like it interprets line, and then the last line is where it executes. So when we put it in the first, when we put that whole thing above the definition, then we execute it first and then interpret it, and that's why the error.
No. So see, that is a natural conclusion, but that's not exactly what's going on. So it does read it in line by line, right? But it doesn't necessarily execute it at the end. What I mean is, this is also perfectly valid code. Right? This is not going to cause us any trouble. It doesn't naturally, and in fact, we recognize this from the fact that there is an if statement here, right? we covered if conditionals last time. So this just says, wherever this is, if the name is main, right? That is, if you start executing it, then it'll do this. But the problem of definition is still there. So ideas for what this will do. For that matter, I honestly don't remember. Let's find out.
Will subject be an error?
Yes. So it turns out, yes, it does kind of run at the end. So why then am I against saying that it definitively runs at the end? Well, the reason has to do with, it has to do with like imports. So you can actually call other things into this, which are named elsewhere. And so, this name equal to main need not always be main. Like, but okay, I think we're moving into like esoteric realms, because until you're gonna work with a library, that's really not important. But okay, fantastic. We've done some great work. We have figured out how Python reads a file, which is something which we couldn't do with Carol because nobody knows what Carol does. Let's just go with that. And right, so now let's go back to Moonweight. Input, convert, print. For clarity, most people expect main, so you might as well, in general, name your things like this, right? For the simple reason that you don't want to confuse people who look at your code. So we were discussing variables, and okay, before that though, before we even talk about variables, does anyone remember, or have you guys seen how we'd like get started with this in the first place? Like, we're all comfortable with print statements, yes?
Yeah.
By the way, if it sounds like I'm trivializing things, I'm really not. Print is actually super complicated as well. Just heads up, what print does is it attaches to a console, and that's a special kind of different device, like low level. So it is not trivial. Even prints are super tough. On the moon, right? On the moon.
Sorry, what is tough? What is super tough, you said?
Oh, working with print statements. Like actually getting things to output to the right location is not trivial. So like, yeah. But for this particular program, yes, print statements are the least of our concerns. So we've done this. What's missing? And like at this point, we can probably tell what's missing. But okay, let's go back to this for a second. Oh, I forgot I can't. Yeah, I'm used to being able to split my screen, but okay. Right, so let's go back to this. Tell me, what is the way we're going to break this program down? Like, how should we do this? Where do we put the inputs? Do we need any extra functions? And at this point, we all remember pass from the last class, right? That you put a pass when you don't know what to do. But since we've defined it or something like it, we can get rid of pass, right? So what's the next step?
So maybe we can define a variable which is weight.
Mm-hmm. Okay.
Yeah, like maybe my weight or earth weight. And
okay. So question, where do we define the variable?
Before the print, the first print.
Okay.
I would say after the first print statement, we define the variable, input variable, after the first print statement.
Okay. Quick aside, what happens if we define a variable here? Or like, realistically, what is the difference between assigning a variable here,
Yeah,
or...
true. Okay, if we define a variable within the function, it will only work within the function. So now I remembered, we have to define the variable outside the function so that it can be functional throughout the code, not only within the function itself.
But then
Okay.
wouldn't it become a constant? And we don't need a constant because we want to enter any value that we want.
Mm-hmm. So, okay, so the first thing is, in general, yes, we cannot define. So, okay, it is helpful now, since you guys have no doubt covered that, like, you talk about variables and as like things in boxes, yes, with little labels saying, oh, it's an integer, oh, blah, 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 right? Similarly, it's helpful to think of functions that way. Okay, so this little box is the main function. This little box is the global space, right? So there is an inherent program space, which is the default one. And then this is the little main function, right? Everyone is clear with that?
Yeah.
So, and the little boxes are where, different things will go. So, if I put something here, and it's really a top-down sort of waterfall approach. So if I put something here, then it'll trickle down all the way to the bottom, right? If I put something here, it'll trickle down all the way to the bottom. But if I have, say, something, if I define another box here, say another function, we'll get to that. It's okay. Okay, so interesting question though. I would suggest, given the chance, always try to make your program crash as much as possible. Just go nuts with it. It's it's not going to hurt you, and it's very probably going to teach you something, always. So let's start with a variable, and let's say the variable is you guys have, like, okay, how would we name this variable? Let's talk about that.
Maybe earth weight, earth_weight.
Wouldn't you use an input statement?
Right. So they're both right. The input statement, okay, yeah, that's actually, let's start with that. So let's see, input, and so quick question, what happens here? Like, what are we doing here? It ran, right? So would you then say that this print statement doesn't need to be there, or like, what is going on here?
Input is also printing to the console.
Right, it is, but right, so we still need a variable though, right? We understand that. And how would we do this? We still need a variable. So, okay, by the way, this is not necessarily legal everywhere, like in other languages. So let's call it, what was the suggestion? Earth weight?
Earth_weight equal to.
Okay, so now here's the thing. We
input
really
can
don't
be.
need this.
Sorry.
Yeah, sorry. No, please go ahead. No, please. It's always
No,
better.
I'm just saying that then instead of do something, we can write enter a weight on earth, there
Okay.
within the input function.
Let's try that. Okay, so why does it show me that if it won't autocomplete it? Oh, okay, got it. Sorry. Right. Okay, that seemed to have worked. And now we can discuss a lot more about this earth weight. So first of all, I know we talked previously about strings and integers and reals and floats. But where have we specified that? Does Moonweight know? So
now we need to convert this input into a float, maybe.
no, but even before that, what is Moonweight? So let's go back to some of the functional definitions, or rather variable things which we discussed. So we said variables need to be labeled as per their operations. So I say, okay, let's see if we can run an operation. Let's try that. What is going on here?
Since the input is a string, I mean, you cannot do an operation on it.
Okay, but how do we know what the input is? What about this guy?
It's in double quotes, and I mean the earth weight is an input. It's a text, right? It's not a number.
Don't you have to define the input? Like, we kind of mentioned it earlier, but you need to like specify if it's a float or if it's a
We
string.
do, but it's important to recognize that it is inherently something as well. And in fact, okay, so it turns out input produces a string, right? As many of you correctly, everyone correctly pointed out, except me. Input is always a string, no matter what you give it. And okay, the type function, okay, so let's talk about type. I really like type. Okay, so personally, type is one of my favorite functions. And what you can really think of type is it's a special kind of function which just tells you what class it is, right? And really there's nothing else to say about type. But it is very useful because now that we know, then the next step, as many of you pointed out, okay, by the way, how do we convert these things from one to another? How do we convert variables?
You can add a float before the input and add another parenthesis for the earth weight. Or you can, yeah.
Okay, everyone is clear on that? So essentially, we do typecasting, as it is called, as you see it. So essentially, like all of these types that we discussed, say int, float, say string, right? All of these things also form functions of their own. They're little 1:1 functions. So you give this, like all of these can be called to produce different functions, right? I mean, to produce outputs of that type. And now let's see if we can do this. Let's take a look. That worked, right? And at this point, okay, we've done this conversion. So we might want to formalize this. How do we formalize this? How do we ensure that this is always going to be a float?
It needs a decimal point, right?
So that is if we were actually defining it in our code. And in that case, what happens? So you're right. So if I did say, for example, x is equal to 1 and type x, print x, so now we're gonna play around with types for a little bit. So now you're absolutely right. When we add this sort of a float, like a decimal, then it does change. And what this is doing is it's called duck typing. It means it just guesses. So you may be wondering why we can't or why we don't just do something like this, right? And the reason is Python traditionally does not like the syntax. And in fact, it doesn't even support it. This is an error. If this seems weird, then I will. So one of the reasons why this happens is because in Python, like if you do start defining types, then you have to define them everywhere. and that gets very difficult to keep track of. So, which is why in Python, typically you're happy with whatever it just assumes, and then you explicitly demand the type when you need it. So, like if I really wanted, right, I could do this, right? Everyone gets this, right?
Yep.
Excellent. Okay, so I guess that's. So this brings us to another question, another point, which someone pointed out as well, which was very good, that we can just actually wrap this entire thing. You know, we've seen, and this should give us the right answer, right? Everyone thinks it'll work? And it did. Right, so we've done that. And the next point is, okay, now, this is another fun point. We want to convert this, right? But we already know, okay, well, let's do this in steps. Is there any difference between earth weight and the conversion factor?
I mean, we have to multiply it with 16.5%. That's what you mean, right?
Yes, but where would we put 16.5? Like, how would we give it to our program? And is it somehow different from earth weight?
So maybe we can define another variable because we're going to perform an operation on earth weight.
Okay, that's one thing. So let's call this variable
Moonweight.
okay, Moonweight. And it's a percentage, so we do this, right?
Yeah.
And
Into
oh, okay, you want to go it in one shot? Oh, okay, sure. Earth weight. And does anyone recall how to print a variable?
Print, and then inside the parentheses without the quote marks, we put the name of the variable.
Brilliant. So a shorter way of doing that is also just putting a comma here, and then we can just do that in one shot. But it's true. It is equally valid to write it out. Okay. And that worked. I guess we're done. And we actually are done. I mean, there's no doubt about that. But there are a couple of things which we'll still discuss about Moonweight.
so, just a quick question, like when this worked with, when I was thinking it because of the lectures, I thought that I have to add a plus string Moonweight. I thought I'll have to convert Moonweight into a string. So for some reason, I did an additional step.
So this is actually a natural question, and the truth is, you would think this should work, but we already discussed why this doesn't work. So if you want this
I
to
mean,
work,
I did plus string, yeah, and Moonweight, but like you didn't do that step, so maybe that's not necessary.
so the difference, it is actually a very important point, and this is why I said even prints are not as simple; they're deceptively simple. So here's the thing: S3 4.5. Okay, so this versus test plus. Now these look the same, but underneath what's going on, okay, well, they don't even look the same because strings have spaces. So what's going on here is that the print statement can deal with multiple values, right? So if you tell it, okay, this is one variable, then this is another variable, then it'll print them using the right class. But when we do when we do operations inside print, okay, it's useful at this point to recall, I don't know, it's kind of like a Russian doll thing. So inside a print, if we do an operation, so really mentally what's going on here is that in one case we're just saying, hey, okay, this is print, and we are printing out two different things, and print is like, okay, whatever, I can do that. In the other case, we're saying there is an operation going on here, and we know there's an operation because there's a plus, and we just want to print the result of that operation. Does that make sense?
Yeah. So okay. Yeah. I think what someone mentioned, concatenation. I always forget to pronounce it correctly.
So yeah, the operation is formally called concatenation, but we can just call it plus of string. Okay, that, I mean, it's okay. And so this is important because what that means is that what's really going on in the second in this case is that this is equivalent to saying, okay, I have, I don't know, some operation, right, x, which is equal to be more precise, to clear our notation up, this is equal to my substring. And we're saying that the second one is actually performing this and then just printing out the result. Okay, to make that one clearer. Is this and the reason why I'm putting this like this is okay, yeah, it doesn't have a return type. If you think about it in these terms, you will never run into print problems. Okay, if you think that what you're doing essentially whenever you do an operation, any kind of operation, you put a multiplication statement, you do anything, then if you think about it in terms of you actually making a function, because few people, I mean, this is probably not an error which seems like something you'd miss, right? I mean, when you look at this, you'd say, hey, well, wait, isn't there a problem? Like, we're trying to add different types. But often with print, you might think, oh, well, it's a print. But it's actually not. It's a nested function like this inherently. So the rule of thumb is, well, you know, try to print variables and try to like do everything else outside before the print statement. A good print statement is just a bunch of variables. Does that make sense to everyone?
Yeah. That gives another way of writing print.
Yeah. Okay, so one other thing about Moonweight, which is important again, and that is, it has to do with this guy. It has to do with this thing here. Does anyone have any ideas why I've highlighted this little guy here and I'm saying we have to talk about this?
We can make that its own variable.
Right. And what sets that apart from, say, Moonweight or Earthweight? Like, okay, let's make it a variable. Let's call it ideas.
Conversion factor.
Conversion factor. By the way, good. It's very good to have names which are so this is called snake casing, the one with the underscores. It is the Pythonic way of writing variables, and you should keep it short, but it should still be descriptive. So, for example, in some cases, you might get away with doing this. You know, conversion, as long as you don't do any convolutions in your code, you might get away with this. Okay. So, right. Did I just zoom this in somehow? right? And I say, okay, that is great. But okay, is there something different about this one compared to this and this?
They're
And
all floats, right? They're all floats with one being a constant float.
right. So let's try to develop that intuition again. And to do that, we're going to talk about the flow of the program. The flow of the program is Python will go in, right? Python will, it'll say, hey, where's main? And then it'll be like, okay, I see main, and I see that if I'm in main, then I have to execute this function, whatever the name is. And it'll go in here, and then it sees, okay, earth weight, and then it gets this. Okay, so first thing, this is a user input, right? So Python does not know what this is, right? This depends. If this is Moonweight, then again, Python has no idea about this. Do we understand why that is? But right from the beginning of the program to the end, no matter how many times we run this, we know this is actually 0.165. I know it looks like crap, but it is. We know this box, right? No matter what we do, no matter what we give to Moonweight, no matter what we give to Earthweight, no matter if we give it junk values and it crashes, we always know that this is going to be 0.165, which makes it kind of special, right? I mean, few things in life last forever. And so we all understand that it's a constant, right? And that therefore it's different from the other variables.
Yeah.
Right. So it is customary, and the reason has to do with when you're dealing with large projects, then it just makes life easier. It is customary to put constants not always in global, but definitely not in functions. So what I mean to say, the reason why I specify not necessarily in the global space is often you might just say, hey, you know what, I think my constant should live in a separate file altogether, a separate piece of code altogether. But it is definitely kind of frowned upon to put constant terms in functions. And this is just, it's just logistic. It has nothing to do with the actual program. And on the same token, it is customary. It doesn't have any meaning for Python, but in other programming languages, this form of uppercasing does matter. So by convention, we keep to the same convention. We say that, okay, if it is a constant, and the reason is actually, you can understand why we care about this in the sense that it does kind of make it easier to see at a glance. Like you look at this program and you say, hey, okay, there's one thing which I, as the programmer, know about this program before I get user input. And I know that this is the factor and I can change that, right? So everyone is clear with that?
Yeah.
Is it similar to like Kara when you have to do definitions for new snake casing words you make?
Yeah, these are all conventions. So the difference between convention and what is allowed or legal is just at the programming language level. So if we were using a different language, then for example, for example, like you know that like in Python this breaks, right? This is not allowed, and this is something which is like not allowed at the program level, at the compiler level. Python itself doesn't like it. But as I mentioned, this is something which is by convention. Python will not care either way. We already saw that. But programmers do care for some reason. Not me, but yeah. Right. We have finished Moonweight, and it took, my God, I think it didn't take all that much time, no? Okay, so now I actually have to leave soon, but we still have some time to cover 8 ball because there's no way I'm not going to do even later. That would just suck. So let's talk 8 ball and 8 ball. So is Moonweight clear to everyone, by the way? And the reason why I'm talking a lot about Moonweight is, believe me, variables and what they represent are something which you'll be struggling. I mean, I wouldn't say struggle, but it is something which people struggle with all the time. And it is especially important to Python because as you'll see like later, if you start doing machine learning or something, there are a lot of different kinds of variables based on like and the reason is, okay, we discussed this briefly, so let's just cover that once again. Remember how I talked about space and said, okay, hey, an integer takes up less space than a string, right? We remember that. So it turns out, as you can imagine from the idea of shapes, there's a whole host of arrays and different types. And when you start to convert these one after the other, like it can get really complicated. So it is very, very, very important to keep what variables you're working with and how to convert them in mind. If you do, then you will not have any problem moving forward. Here we only did print statements, but any kind of data which gets thrown at you. You get an image, you're like, hey, well, okay, I know what type this image is, I can deal with it as so-and-so features. If you get variables wrong, your program will crash and Python will not tell you why, which also brings me to a quick story, which I should have maybe started with. The Challenger, I don't know if you guys know this one. So there was actually a NASA space shuttle which crashed because of a Python error related to variables. You guys know about this?
The challenge.
Is it when Fahrenheit and no metric system difference or what?
Yeah, it was at the heart of it. It was a variable problem. So and my constant complaint about that is, hey, if you'd used the statically typed programming language, then that wouldn't have happened. But yeah. So the basic problem was they had something like this and they didn't have any check on this. So they were just hoping that the that the input which was received by this was of the right type. So when it wasn't, then it just crashed. So which is why actually I would say, although both of these are valid, it often makes more sense to allow it to be a duck in the beginning and then enforce it later. Whenever you use it, it's a good idea to explicitly, because here this is a short program, but this could have easily been like 10 pages later, right? And in that case, I don't want to look for earth weight and I don't want to guess what earth weight is. So I will prefer to convert, right? Okay, yeah, I think everyone did fantastic on that. 8 ball. 8 ball is fun because 8 ball is, how many of you guys have played with an 8 ball before?
Just
have.
the one in pool.
No, so the 8 ball is actually, in fact, I don't know if there's an 8 ball. There must be one. Ooh, I hope we don't get anything weird.
It's in Toy Story.
Yes, yes, it is. And oh, by the way, one of the first things. Hello, 8 ball. Right. And this seems like magic. Well, not this so much, but sometimes things seem like magic when you ask it and it keeps telling you things. And funny story, this is how artificial intelligence starts. This is how you trick most people. Till date, if you really want to build a very smart system, you'll just do what we cover here. Okay. And now, does anyone have any idea what we do? Okay, so let's go through the problem. Okay. Write a program that continuously prompts the user for a yes/no question and then randomly selects from a set of canned answers. Classic responses are these. Okay. Pick any 5 or, fun questions like about Carol. By the way, like Carol apparently is non-binary, which we actually asked Chris, and he said that like Carol is, doesn't have a gender. So yeah, not that you have to have a gender to be married, but okay, whatever. Right, everyone, let's break it down quickly. I mean, don't feel pressurized, but yeah, let's try to think this through. What do we need to do?
Have a statement asking that ask a yes or no question.
Okay, and so the first thing is by the way, yeah, now would be the right time to introduce that. One of the things which will always help you when you're designing a program is this concept of flow, right? And we saw briefly how it was useful in the last one, but if you ever have questions, like if you ever see a problem and you're like, hey, where do I start? This seems like a big problem. I don't know what to do. Then what you need to do is think about what the program will do. You have an execution flow and it starts with the first step. And that first step in this case is prompt for an input, right? As someone mentioned. Prompt. And then, from that prompt, you can make this visualization as complicated as, I would say keep making it complicated until you get a grasp of it, in the sense that you can say, hey, these are the variables, I have maybe constants going in this, maybe something like 35 as a constant of for some reason. And I have these outputs, and this really helps. I can tell you there's no problem which can't be solved this way. Almost no problem. So yeah, just when in doubt, right? But in this case, we know evaluation loop, right? What is next? So we wanted to prompt. Okay, how many of you guys have seen random before?
Not yet.
Okay, so now honestly, there can be a whole, and there can and are whole classes on randomness, because it turns out, okay, I don't actually get into this but we can do it very slightly. What do you mean? What does it mean to have a random input or a random thing?
Would it just be a variable? Like it can always change?
Right. So now this is one of the reasons I said, what we cover here is actually going to be similar to a lot of high-level concepts. And in fact, the sad truth is random is actually playing a trick on you. It is also selecting from a set of canned answers. It doesn't, so there's no true randomness for computers. Instead, it will literally give you one out of a set of canned answers. The same logic which you use for this 8-ball is essentially what you get out of random. Like, that is it. And it is one of the most, it sounds amazing that, oh my God, it's a random number. No, it's actually just the same logic scaled up. And this is why I mentioned, a lot of other things like chatbots and everything. They're all canned answers. The magic 8-ball is, the holy grail of all programming. Everything is a canned answer. So moving on beyond that philosophical discussion, let's try to write some code. How would we do this? So as someone mentioned, we need an input. So that input would be a variable, yes? As someone else mentioned, because it has to be random. Names, suggestions for our input.
Question.
Okay. Sorry, what was the second one?
Yes, so maybe like prompt question or something like that.
Okay, let's go with a hybrid question prompt. Okay, and right. So this is something we don't know what yet. And then how do we get one out of all of these guys?
Would we create a loop?
We could create a loop. Yes, very good. But okay, yeah, actually, let's go for it. Which loop? For loop, while loop?
While loop.
Okay. Condition.
Receiving responses.
While question prompt, maybe?
Okay, right. So in fact, this is a very good point. This brings up a very interesting point. A loop seems natural because we are, because of the evaluation loop and all of that. But what we really need to ask ourselves is, we're actually given a prompt, yes? Like this is some input. Give me question. So what are we trying to loop over?
The answers.
Okay. So in that case, what you're saying is we're trying to loop over answers. Now, that's very good. If you recall from the last class, we discussed that, remember how we did that trick with the directions? We said that, hey, I know how many answers there are.
So, as in, do you want to use the for loop because you know the definite answers, the number of definite answers?
Right. So is that clear to everyone why we would prefer, at the moment, why we would prefer a for loop, or why or where we might want to use a while loop? There is still a very important place where we would use a while loop. In fact, that's the second option. I don't know if we'll get to that. Okay. But is that clear to everyone why we would think of a for loop?
Yeah.
Okay. But wait, aren't we getting ahead of ourselves? Wait a minute. Program should prompt the user to type a yes/no question and give a random answer. So now, okay, let's go back to the 8-ball and see what is actually going on. So we are taking a user input, and then okay, let's do a for. Let's say oh wait, yes, now there's so much to unpack here. Okay, so the main thing to unpack here is, well, I already just showed it. So this is called range. I think everyone is seeing range for the first time.
Yes.
Yeah. Range is actually kind of simple. I mean, it has its complications, but it is essentially you use range in loops most often. Like, yeah, I mean, I would say for the moment, what you need to know about range is that you simply, okay, so let's break this down a little bit more. Okay, I'm just going to disable that prompt because we don't need it right now. Right, so what happened? What is this error and why is this happening to us?
Because it is not a variable anymore.
Right. So because this isn't, I mean, we'll get to this in the later weeks. I'm not really going to go into this so much, but very briefly, when we do range and this, we're basically telling it to iterate over, like from start to stop. So this will go from 1, 2, 3, 4, right? And the only reason why I'm introducing this here is because, you know, we already had a great run with the for loop last time, and we can't do that without learning this new syntax at the moment. So yeah, cool. And then now here's a question for you guys. Why are we iterating? Like if you recall, whatever the user inputs has no real bearing on what we output, right? If I say hello or okay, it's bad, but like if you read the question, you ask it a yes no and it tells you the answer. This is important. It just tells you the answer. It doesn't make a decision here. In fact, that's why we discussed randomization, right?
Yeah, so it has to pick up so many random answers from all the answers we give it.
But because we actually reached this point, let's try to think this through a little bit more. Let's not just go with it that way. So say we have gotten question prompt, and you know, for some reason, because it is a perfectly valid way of thinking, we say, hey, well, you know, I'm just gonna. By the way, like, how will we actually encode this? Like, I just want to know like what everyone is thinking the process is. Which primitives will we use? How will we actually print these out?
Since the statements, should we take them as input functions? I was very confused. I tried to go through it before the class, but didn't reach an answer.
Okay. Okay. So let's just start with the most basic way possible of. Okay, I'm just gonna go with 3 right now.
Wait, if we're using range, don't we need numbers instead of sentences for the?
Yes, we do actually. And in fact, it's not just because of range, it's because of anything, because even when we make a random choice, okay, but I'm getting ahead of myself. We've not covered random yet. So this is our primitive. And the reason why I'm calling it a primitive is this is what we know how to do already. We know that, okay, if I have statements and I want them on the screen, I do this. Next point is, we're breaking this down slowly, is that we say, hey, okay, now I'm getting a question. That's okay, but we're not doing anything about the question, right? So the first thing which you'll notice is, hey, I don't want to print all of these, right? I only want to print one of them, right?
Yeah.
So we need a condition which will choose one and suppress the rest. Is that clear?
Yeah, makes sense.
Okay, so let's try to write this down. So we found that the first thing we found is that we can print statements, but don't want all of them. So the natural idea which came out of that is suppress the rest. And what is the primitive which we have, which we know, which can do this for us?
Would it be if-else statement?
Yes, that is right. Is everyone clear why it is going to be the if? I mean, I think we've really only covered the one conditional, right? So whenever we see an if this then that or condition, then we say, hey, you know, I know what to do. If statement. Okay, but if what? So if is brilliant, if is the answer, but what do we do with if?
If it's a prompt question, like, and then you give the answer.
Okay. But at this point, we might. Okay. So let's do it like this. We have two separate problems, parts of the same problem. Part one is, I mean, one part of the program is the user gives an input and the program gives an output. But these two are fundamentally disjoint from each other, right? We know that because the question said randomly, it doesn't really matter. Whatever this guy puts doesn't have anything to do with us. And so whenever you see this disjoint interface, but you still need to communicate, then you know that you have randomness, right? This is where the randomness comes in. But then random what? Again becomes the question. And, you know, it would be nice at this point, I'm sure, like, everyone might have thought of the obvious reason, I feel, but like maybe no one wants to say it. What if it just gave me a random answer? What if it just printed one of these, right? That's what we're looking for. That's what we want. So if there was some magic way of doing random print, that's really what we're looking for, right?
I'm looking for a random function that can randomize strings. Like I all the random functions that I was thinking could randomize numbers, like integers between 0, 1. But I was trying to find how to randomize statements. And maybe
Right,
there's a function for it.
so the truth is, like, the simplest answer is always the right one. Like Occam's razor is always true. We want one random sentence out of 3 sentences. So we think we want a random print, right? And how do we get that? We only have one way of getting that. We have an if. And what can we test with an if? With an if, let's write out what a basic if statement is. If I don't know, hello. Oh, right. Yeah, this is, wow, it turns out I did not realize that there was so much to do in this in the 8-ball. I'm sorry. Okay, let's do this. What is happening?
It didn't suppress the others.
Right, but it did suppress something. That's a start. But before that, we did something here. This guy. I think most of you are seeing this for the first time. Or does everyone know about this one?
First time.
Okay, excellent. And this is very important because this is the solution to many things in life. Okay. So we know what we inherently, because I've already used it in an if statement, there's no point, you know, hiding that. It's some kind of operation. And when we think operations, what have we got? Like some kind of comparison, yes, because it's in an if statement. And maybe if I'd done this, then this would have been less confusing because everyone knows greater than, less than, right? You know, B goes this side, B goes that side, you know what's going on. What about this guy? And this is really important for variables because, okay, what is the difference between what I did to A and B and B and C?
that you're assigning the value b to a when it's equal.
Okay, yeah, we've been seeing a lot of equal to signs. And in fact, for that matter, we've seen this little guy here as well once before. And at that time, we discussed, does anyone recall what we discussed about this little if statement here? What did we say? How did we justify this little if statement here? Okay, to recap, we said, when we run our program, if it's the start, that is, if we start in this special space called main, if our starting space, which is name, is equal to main. So if name is equal to main, then we execute whatever is here, right? That's what we discussed. Everyone remembers that?
Yep.
Right.
Yes.
And that actually brings us, let's write it down to make it clear. Huh? If something is equal to does this make it a little bit clearer? So in one case, we have well, and in fact, let's do this again a little bit. This is an important concept. It is a difficult concept, so it makes sense that it takes time. Don't worry about it. Here we have A. A is some type. We don't care what type it is. A is just some object. Here we have B. B is also just something. We don't care what. Now we say, hey, you know, A is equal to 3. A is not 3. B is whatever. Then we say, hey, you know what? I'm going to do A is equal to B. In fact, I made a mistake here. A is now B. That's the right one. So now A has the value of whatever B was. So if B was 4 at the end of executing this statement, A will be 4. Right? This is something which everyone is clear on.
Yeah.
Right. But when we do this, then we go back to the sentence. We say, if something, in this case A, if A is equal to the other thing, we have basically converted the assignment operator to a test. Because we know the statement, right? We know this clearly from the main, you know, name main thing. Name main, they're very close together for some reason. I don't know. So I feel like we might want to do this a little bit more. So let's actually do that for a few seconds. Let's start with some there.
So then the 2 equal signs is more of a comparison.
If you said do 2 equals mean comparison, then the answer is yes. And in fact, Okay. Remember how I said type would come in handy? What is the type of this? Because it's all fun and games before when they're simple. Now what? What would be the type of this? Well, let me just find out. It's a bool. Python has special. So in Python, this is if I say x is equal to true, then that has special meaning. X is now a bool. So it is, and this is a special case because yeah, as you notice, we have not defined it as a string, but it is still a character. In fact, size-wise, it is actually, well, that's not. But okay, let's talk about this for a few more minutes because it is very important. And don't these make sense? Isn't x not equal to b? So shouldn't x equal to b be false? As it is? Is Zoom trying to throw me out? Oh, what is happening? Oh shit. Okay, guys. So how do you feel about this assignment operator? I mean, sorry, about this equality assertion. It is formally known as the assertion operator because we're basically testing assert. Like, does anyone want to like cover some examples of where this might like, okay, this is true, the first time you saw true on this because b is definitely equal to 4, right? This is still true. Oh, this one is a fun one. Does anyone know why this is true then? So the answer has to do with something called implicit type conversions. And so the upshot of it is when you have an integer and a float, and these are just some special rules. Again, they're not necessary for you to know. As long as you do explicit typecasting, you don't need to worry about this. But the long and short is, when there was that big crash and all of that, like a lot of people said, hey, why can't Python be a little bit smarter? And so Python is a little bit smarter now. But what I mean to say is that when you have a lower, so lower as in space lower, so an integer takes up less space than, I wonder if there's a size of defined here. Yeah, no, that's a different module. Okay, yeah, never mind. So it is enough to remember that an integer takes less space in memory because integers are just whole numbers 1, 2, 3, 4, 5. You can imagine, and a float value is like 1.89763221, right? That's bigger, harder to remember. So integers, whenever they are in a relation with a float, both of them become floats. Okay. This is not something you need to worry about. If you're worrying about this, then you've probably made a mistake in an earlier stage and you've not explicitly detailed your types. Okay. When you explicitly detail your types, you don't run into this problem. Second thing, I kind of feel like the assertion operator is not clear to everyone. Am I right in feeling that way, or is it just?
It'll probably take some time.
Yeah, I'm sorry, but actually I need to go in like another 15 minutes. And okay, so let's kind of work through that. So the assertion operator said, if this is equal to this, then it's true. That's it, quite simply. Now, none of these things are equal. Hello and hello, because one has a capital, the other is not, right? But there is something fun which is happening. And that something fun is look what happened. Did you see that? This guy showed up. Whereas before, what have we done here? We are suppressing one of the print statements. This is exactly what we wanted to do. Now, true, we wanted to suppress all of them, but yeah, it's a first step, right? Everyone sees how this is being suppressed and unsuppressed, right? Behold, now it is there. Why? Because the if statement evaluated to true. In fact, let's make this even simpler for now. You know, let's forget about assignment operators. See, we now have suppressed a thing. Everyone sees that?
Why is it suppressed? Like, how does that happen?
Because if this is true, then it'll print it. It's inside the if statement. That's a very good question. Thank you. Remember how we broke our program into these little boxes? So now this is inside this if statement. This print statement is only here. And only if this is true. When we say this is true, see, if this is true, whatever this is, in this case, we're literally saying it is true, you know, whatever it is, it's already true, you know, don't worry about it, it's true. Then it's gonna come up. We have broken out of this box. This evaluates to true and it's gonna come. If not, you know, we say you know, false, we're telling it, no, whatever it is, it's not true, it's a lie. Then it's stuck in this box, it doesn't come out. Is that clear?
So it didn't have anything to do with the punctuation, the period?
Oh, no. Oh, you mean this guy?
Yeah, the B, bay.
Punctuation. No, this could be anything. It's a string. So the condition is here, and the reason why I'm using true and false here is because honestly, what we would be using here is like we can use anything. So anything which is true or false. Now, obviously, this is a false statement. Maybe this is clearer. 1 is not greater than 2. So whatever is inside this if block, right? This little if block is not going to happen because the condition was not fulfilled. And in many cases, like in many ways, you'll remember that when we were talking about loops, then we talked about starting from one state and moving to another state, yes? And we evaluated our condition based on our end state. Here, we're evaluating our condition right at the beginning. We're saying if, then. So if it's untrue, right, it's just not going to happen. It's not even going to make one single step in that direction. It's not going to print. It's not about one step. None of these will show up. But if it was true, then we are in that box, right?
Right.
Excellent. So this is the basic concept, which is okay. There's one more concept which I'm going to go through. You'll notice that today I'm not going to actually reach the end of the solution, but we have to go. But the other important concept which we've actually already discussed. Okay, can anyone tell me now how would we solve our problem? Like we have a suppression operator. Let's go back to our breakdown. we know in some sense how to suppress things, right? Not necessarily suppress the rest, but we have, you know, some concept of suppression. What's the next thing? Okay, so it's okay. The next part is random. We see that random is actually, you know, here, everywhere. Randomization is important. But what random? As someone pointed out, may have heard that there are only random numbers. Right? So this is just now, so you know, this is just going to be like a random number between anything between here and here. Okay, like to prove it, let's actually I'm missing something. So why did that get done? So evaluate this to false. Let's try this again. That is supposed to happen. Very weird. Well, we have come up with a bug in Carol. Well, not Carol, the IDE. Brilliant. But okay, we can now in the terminal you see that this is working, whereas it is amazingly not working here. Fun fact, that means you will not be able to complete this. Oh no, now it's running. What the? Okay, I'm not even going to get into that. I don't know why that happened. But the fun fact is that we are definitely getting random numbers now. Okay, again, yeah, we are getting random numbers, but if you noticed, we didn't get it once. We got the same number. And this comes back to what I was telling you guys about, that, you know, random is also just a set of canned numbers, and it's choosing them randomly, right? Quote unquote, random. So why did I show you this? Do you have all the parts to solve this? Now, if not, I would like someone to tell me what is missing. And don't take this in any way whatsoever. I mean, this is by no way a prescription to solve the problem. There's a lot left to do. But tell me, what seems to be missing, if anything, from here? So a random choice. I'm just gonna draw this here. Oh no, I'm gonna type it out. Could you guys like, would it be useful if you guys would tell me what would be missing from this, or what you feel is still necessary for us to program? If you remember, in the beginning we said, hey, what if I could just get a random sentence, right? I just want a random sentence. And then we said, hey, I can only get random integers only, you know. And we said, okay, I don't know how to deal with that yet, but I will do something with that. And then we said, hey, suppress things, right? And then we saw that you can suppress things by leveraging if. Depending on the truth value of your if statement, you can suppress or enable different parts of your program, right? And together, right? Together, we have a random integer goes into our program. Now, on the side, a user is putting in a random string of his own. Okay, we don't even care. And we, as the program, are outputting the answer to life from us. And how we are choosing the answer to life is at random. And what we're doing is we're taking a random integer, right? And we're saying if something with that random integer, then some sentence. Is this something which we all agree on?
Yes, I think so.
Okay. So guys, I have to run off today. I mean, if everyone, like, I would urge everyone to take a look at this document to play around with using this. A fun way to play around is if you use the interactive thing, that is to say, if you just type Python into your terminal, oh wow, then you can actually just, I'm gonna leave this code out here. It's not much of a code, but I would suggest that you guys play around with this and become comfortable with what the assert is doing, right? And once that happens, then try implementing this, right, in these two steps. And if necessary, and if everyone would like, we can always have an extra class, but I'm really sorry, but I have to leave, like, kind of urgent. But it was great.
Yeah, no problem. Thank you.
Yeah, sure. I had a great time. I'm sorry if like some things were unclear. We will cover them again. You guys were awesome. This was great. So see ya. Have a great
Thank you.
weekend.
Bye,
Rohit,
everyone.
Bye.